So in this video we first compare regular trajectory shaping guidance algorithm and the modified trajectory shaping guidance algorithm for single vehicle path following. So you can see we have the vehicle here and we have a virtual target which is on the path, and the objective here is to apply lateral acceleration for this vehicle so that this can be on the path and maintain desired distance between between the virtual target and the vehicle. And the virtual target here basically regulates its velocity so that it slows down or speeds up to maintain that distance. So the lateral control is on here, and the longitudinal control to maintain the distance is applied on the velocity control of the virtual target. So let's play first the regular trajectory shaping guidance for larger for D star 1.9 meters. So you will see that the regular trajectory shaping guidance for a larger D star does not converge on the path, but it converges on the offset. And it's because the equilibrium point for regular trajectory shaping guidance is not on the path, but at an offset. So we'll stop this one. And now we will run the modified trajectory shaping guidance as described in the paper, and you will see that initially it has some offset, but uh, slowly it converges on the path, and it is because the equilibrium point for the modified trajectory shaping guidance lies exactly on the path, and it maintains the start distance between virtual target and the vehicle. And this particular guidance algorithm is very beneficial for platooning aspects so that we can control the distances between vehicles. So now this will be applied to platooning scenario. So now in this we are applying the modified trajectory shaping guidance for multi-vehicle path following problem. So in this case we have a virtual target on the path, and this vehicle follows the virtual target, and the virtual target regulates its velocity to maintain a d-star distance, and a lateral acceleration is applied based on the modified trajectory shaping guidance to be on the path. Similarly, for this vehicle, number 2 vehicle, this is the virtual target, and vehicle 1 regulates its velocity to maintain the start distance between vehicle 1 and 2. Similarly, for vehicle number 3, 2 is virtual target, and so on. So we'll see in this case we are using 6 vehicles, and we just play here. So we'll see that all the vehicles basically converge on the path and maintains distance of 0.7 meters. Initially there was a little offset, but eventually they all converge on the path. So now in the next video we will show you the same thing in the experiment. Now the disturbance was given to the front vehicle, and you will see that they converge back, showing that the vehicle is robust to disturbances. Experimental validation of modified trajectory shaping guidance for multi-vehicle path following. So in this we are using Pololu 3 MPI ground robots, which has a differential drive. We send PWM commands to 2 motors and regulate velocity and turn rate. So this is the first vehicle that follows the virtual target, and then every other vehicle, the second vehicle, vehicle 1 is the virtual target, for third, second is the virtual target, and they regulate their velocity to maintain d-star distance. So let's just play it. So we'll see that everybody's converged on the path. Now, disturbance will be given to the third vehicle here, this one, and you see after it's disturbed, as it was shown in simulations in the experimental uh, validation. Also, vehicles converge back to the path after the disturbance. In the next validation, what we will do is we will give disturbance to the first vehicle that is following the virtual target. This is the first vehicle, and disturbance will be given to this, which is following the virtual target, and we'll see what is the disturbance is in terms of lateral acceleration. Large lateral acceleration disturbance is given, and it will be given now. You see a large, but all the vehicles initially disturbs but then converge back to the path, and that shows